Okay, the last, at least of today, related rates example I wanted to share is this one. It gives you a diagram drawn, it's a right triangle, and some information. It says, in this triangle, it says theta increases, so this angle is getting bigger at a constant rate of 3 radians per minute. So let's first start out with that variable. Theta is changing, and it's radians per minute. So the variable for theta would be d theta dt. Just like if the width is changing, it would be dw dt, or the area is changing, it would be dA dt. Those are all variables. Theta is a variable for an angle. So if it's changing, it would be represented by d theta dt. And if you look at the units, it makes sense. Theta would be radians. That's how all of our angles are measured in calculus. And time would be in minutes. It's asking what rate is x increasing. So it's asking how fast x is changing. When x is 3. So we have to set up a normal equation that relates our variables. Normally, when you see a right triangle like this, you're going to go right to Pythagorean theorem. That's not going to help because Pythagorean theorem has nothing to do with angles, only sides. We have to relate theta and x with some kind of relationship. And for a right triangle, think about the other things you know about relationships in a right triangle. Hopefully you did think about it and have the answer in mind. I'm going to write it right here. That's what relates the angles of a right triangle with its sides. So, since we have this angle, we are looking for how its opposite side is changing, and we know its hypotenuse is going to be 5. We're going to look for the relationship that relates the angle with its opposite and hypotenuse. There we go. Sine. So we're going to start out with this equation. This is our regular equation like we always do. Sine theta is equal to opposite over hypotenuse. So now we're going to take this and make it a related rates equation. So first I'm going to rewrite, because 1/5 is a constant. Now the derivative sine of theta, remember it's a chain rule. So that's derivative of the outside, which is sine. Leave the inside alone. So I'm leaving theta alone. Then times the derivative of the inside, which is derivative of theta with respect to t. On this side, you just have to take the derivative of x with respect to t. And there's our related rates equation. Let's see what we got. We're looking for dx dt. So we don't need to fill that blank in. We have d theta dt. It's 3. We don't need x, even though it's given, but that's not within our equation. However, we don't know what theta is. So we have to figure out what theta is at the moment x equals 3. So we actually do need x, but in a kind of roundabout way. We have to use this x equals 3 to get theta, and here's the equation we're looking at. So we need to be able to do this problem. We need to be able to figure out what theta is first. Otherwise, we have too many variables. So we know sine of theta, the moment that x is 3, that's what it's saying, is 3 over 5. So now we have to solve for theta. So if you remember, you have to inverse sine both sides. Now, there is a way to do this without a calculator. You can plug in the inverse sine of 3/5 in here. You did that in trig last year. You may or may not remember. If you have time and you remind me, I'll show you how to do that. But right now, I'm going to do it with a calculator. So I'm going to type in inverse sine of 3 over 5. So I get theta equals 0.6435, and there's more. You must be in radian mode here. This is radians. Look, it has to be in radians, and since we're in calculus, we have to be in radians. Otherwise, the derivatives don't work. So we have cosine of theta, which is 0.6435, etc., times d theta dt, which is 3, equals 1/5 dx dt. So I have to solve for dx dt. One thing I'll tell you right here, see that cosine of 0.6435, etc.? I'm going to type it in, I'm going to type cosine now, and then just arrow up to get this answer that's stored in my calculator. That's why I used all the dots. I'm going to use every decimal that my calculator knows, because it's just going to be it's not hard to do, and it's going to be a more accurate answer. And believe it or not, this is 0.8. So that does tell me I probably could have done that without a calculator. Times 3 equals 1/5 times dx dt. So 0.8 times 3 is 2.4. So dx dt would equal 2.4 times 5. And that would be 5 times 4 is 20. 5 times 2 is 10. And 10 plus 2 is 12. That's it. So that one looks like it's pretty challenging, but isn't all trig pretty challenging? So if you have questions after watching these, please let me know.